If you watched my last video and saw the vector word problem where we had just magnitude and direction with no real context, then you're going to see that this problem is just taking the same sort of scenario. We're being provided with magnitudes and directions again. We're taking that same kind of scenario, just adding a generic layer of information to it as to what those forces are. So in this problem, we're seeing that a student is helping their teacher slide their desk to a new location. And it wants to know the resultant force exerted when we combine the student and the teacher's forces. So it's saying that the student applied a force of 120 newtons at 60 degrees, and the teacher is applying a force of 180 newtons at 40 degrees. And so in general, what we're looking at is a situation where, let's say that these forces resulted in an exact displacement of some kind. The student is kind of pushing in this direction, the teacher is sort of pushing in this direction, and as a result, when you go to combine these things, you're going to see that instead, your actual resultant force would be something here in between that. And it would be larger, it would be combining those together, because they have the same direction for x, they're both heading to the right, and they're both pushing a little bit up. So we expect a combined force that's a little bigger in both directions. So what I want to do is not worry too much about what that picture is going to end up looking like, although there are methods in which you can draw parallelograms and actually work with law of sines and law of cosines to figure out what this resultant force would be. For me, my approach that I prefer, that I've really kind of locked in on in the last year or so myself, is what I've been doing in previous videos is converting these to their component forms. If I know their x and y components, I can just add them together, and I can work this thing through. Now, this says find the resultant force, so all we want is the magnitude here. We don't necessarily want the direction. So let's go ahead and find. Let's say S represents the student direction, and T will represent the teacher directions. And the nice thing about this is if you're playing this as a how fast can I get through this problem, I just want to get it done, I want to understand it, but I mostly just want to know how to do it at the same time. What you can do is go, okay, all of these follow a set pattern, magnitude, and then either cosine or sine, and then the angle or direction. So for a student, the magnitude's 120. So I'm just going to go and jot down 120, and then I'm going to swap to 180 for the teacher. We need the magnitudes for all of them. In the x directions, we use cosine, and in the y directions, we use sine. Inside those parentheses, you put the angle, the direction angle. Here, they're giving me 60 degrees, so the student is going to have a 60 in here. And then here, we're going to have 40 degrees for the teacher. All of these things are values that you can input into your calculator. So what we're going to do is just kind of do that all at once like I did in my previous video. I'm going to take both my x components, I'm going to type them in at the same time. I am going to make sure first that I am in degree mode this time, that's good. So here we go. I have 120 cosine of 60, so that's the student's x direction. And I'm going to add to that the 180 cosine of 40, which is the teacher's x direction. And we're looking at about 197.89. I'm going to round that up to 2 decimal places. So 197.89. Now, they rounded theirs off to really nice clean whole numbers. So maybe at the end of the problem we'll do that, but for now we'll just round like we are. Let's now do our y directions. And actually, let me do this instead. Let's do second entry. And I'll just go replace all of the cosines with sines instead. And that'll save me just a little bit of typing. And there we have it. We have 219.62. All right. So what we have now is our resultant vector in component form. We know the x direction, we know the y direction. Notice how they're both bigger than either of the forces provided by the teacher or the student. We said earlier that we would combine their forces, so we should see forces that are larger. And in fact, our resultant force is just going to be the magnitude of this vector we've created here. So we're just going to go in and apply our magnitude formula, which is just an application of the Pythagorean theorem. I almost never draw that square root bar long enough, but that's okay. We could fix that pretty easy. And we'll just go ahead and plug this in here real fast. And I'm seeing about 295 And let's round that up to 296, because they have whole numbers. We'll go ahead and go with whole numbers as well. Now, they gave us a unit of measure this time, so I am going to include the newtons. Actually, in retrospect, I think in my last video, I may have left that out of my answer. So in the last video, I should have included the pounds, I think is what I measured in that one. But here we have 296 newtons as the resultant force of adding these two things together. And you might look at that and go, okay, by the way, 120 and the 180 that they originally had, if I add those together, if they were all pointing in the same direction, it would just all build on itself. It would just all add up exactly, and it would be a total of 300 newtons. Well, it makes sense here that we're not quite achieving that because we're not both pushing in exactly the same direction. So some of that strength is lost as a result.